we are super excited to be here. I want to invite team of the organizers who put this event together on the stage. Alex, come. Frederick, are you here? Frederick? He's probably still checking on people. So my name is Archie. I'm CNCF ambassador, originator of this meetup, I would say, that we started 8 years ago, and we're still running these events. We hope it's useful for you and you learn something and maybe meet people that working in the same area, space, and you can share your knowledge. Please give us the feedback, how good we are and are we still useful for the community. Anthony Dehani, he is from VMware. He should be here, but you all know him. He's also running Java User Group Montreal. Frederick, he's at the checking on people. He's our co-organizer from Google Cloud. And we have Alex Gervais, who actually I still have Ambassador Labs, but he recently started at Kong. So maybe a few words.
Yeah, thank you. I've been at Ambassador Labs for so long, but recently transitioned to Kong. Very similar role, similar tech, similar ecosystem, so it feels right at home, but in a bigger shot. Yeah.
Congrats, Alex. I was a bit stressed, like when this announcement came about Ambassador. It's been a nice company for community, and we had, I think, the founder of the company speaking at our events in the past. So yeah, if you have any questions about any of those companies you see, please come talk to us. We also want to talk to you if you're interested about speaking engagements. So I don't know if when you were doing checking in, like we try to ask what are you working on, and if you want to talk about anything, the projects that you're working inside of your company, some successes, maybe some failures, or something that you want to share. We really want to hear this, and then we will try to promote you or try to give you something. But like, if you want to present, it's just 10-15 minutes of your time for the lightning talk. So please don't hesitate. And if you're not sure, just come talk to me, Alex, or Frederick, or Anthony, and we'll try to help you out. Today is packed agenda. We're going to start with the introductions, and we'll cover a bit of Kubecon Paris. Then we have 3 tech talks, so we'll try to move fast. So today's speakers, we have Marat, our old-timer from the last meetup, actually. Marat's working at SysDig in Montreal. Then we have Steve. Oh, you're here, okay. So Steve's here from Grafana Labs. So he has like a series of all Grafana projects that they want to share with us. So we might see him for maybe a few events and maybe his colleagues. There's Grafana recently announced many projects around observability, and they're quite new. We all know Grafana dashboards, but this is like all the new stuff that came in. And then we have a special guest from abroad, Chris Grell from Achilles. I'm dying myself to learn about LLM and Kubernetes and Helm charts, so like quite excited about it. So looking forward for these amazing tech talks. A few housekeeping items. Wi-Fi is available. If you want to follow us on the link tree, if you go to scan this QR code, and if you go to this Linktree Cloud Native Canada, you should be able to see something like this. So here you can find all the links for signing in or for our next events. And most importantly, if you want to speak at our events, there's a CFP link. You just need to click and then just say, oh, sorry, not this one, CFP Montreal. You just submit your talk, and then we're going to reach you back and help you to set up for the next presentation. So that's a little promotion. We have a Slack channel, and we have a YouTube channel where you can see this presentations and then also the slides. And I would like to say huge thank you to this amazing company, Lightspeed. I don't know, wave of hands to Lightspeed folks. Thank you so much for having us. I think this is one of the best venues I've seen in Montreal. So we're happy to be here one day again. But I'm very excited to be back at the Lightspeed. Huge thank you to Achilles for sponsoring our pizza today. We'll hear more from them. And also, thank you to our sponsor. That was our single sponsor last year. It was very tough times for us to recover from COVID. Sysdig, thank you, Sysdig. So we have a couple of announcements. Arctic, local company in Canada that is doing this kind of DevOps shop, helping companies automate their infrastructure or deploy stuff on Kubernetes. So they are sponsoring our events this year. So thank you, Arctic. And finally, very excited about Grafana Labs. It's been a long time partnership that we work together, and first time they are our sponsors of CNCF Meetup. So thank you, Grafana Labs. We're looking forward. I have some very controversial announcement. So please don't judge me. I just maybe want to hear your feedback. I don't know if you heard about this project. So Linux Foundation recently adopted a new project called Valky. This is a fork of Redis project. I don't know. Like I think I want to ask you guys, what do you think about it? Like, is it a good thing or bad thing for open source community, or like anybody has like opinion? Maybe like I'm not like working with Redis day to day, but I've kind of had like double feeling about this situation. I feel for Redis company, but also I feel for that they changed the license recently, and this kind of created the situation maybe very similar to what Grafana had in the past, right? Like, but like I feel like Grafana is more open source than Redis today. But still, like it's very similar situation, and like if you want to learn more, there's many articles about it, and every article has its own kind of twist. I think so. Like it's a very difficult situation, but I think eventually, I hope this is going to be a way to go forward, I guess, from this situation. So Redis will continue provide Redis, but with the new license that will not allow other vendors to use it, but it's still going to be open source. But then, like some cloud providers that want to use this, in their cloud solutions, they are like kind of help to start this movement to fork the Redis, and this is going to be an open source project right now. And Linux Foundation is not CNCF, but it's very like it's kind of the same umbrella. So yeah, if you have anything to say, please say it now.
Yeah, I feel like this the same way about what HashiCorp with the Terraform. Like they built an open source tool that got so ingrained in technology stacks that it's just a default technology. And then once we're like hooked to it, I turn around and change the license to it's made a switch. It's a shitty way to do things. It's I don't know. Almost yeah.
I feel I agree with your position, but at the same time, like Elasticsearch, they sold their house to start a company, to start a project, and then cloud providers start to using it and make business, but don't pay them back. Is that like a good way to do the business?
I have an opinion that might be a bit more controversial on the subject. I think that companies going out of open source into closed source is something we should have expected. Yes, it causes issues like Terraform going with OpenTofu. It causes us as developers or infrastructure maintainers issues. But you have to think about the people that own that open source code. And if they want to make money out of it, they have the right to go back to closed source. And so people that open source now have a clear mechanism to go back to closed source. And from that point of view, I think it's a good thing. So if you're a company and you decide to get some part of your code open, you can decide at some point to go back to close, but you have to be aware that there's going to be forks. And from that point of view, it's a win.
No, I personally feel like if the projects in CNCF has a good governance, and like you have more kind of feeling that this project will not gonna change the license because it's governed. But like there's so many nice projects that are not part of CNCF, unfortunately, but they're still cloud native. And I hope there will be in the future we're not gonna have a lot of those situations where people like really love open source solution and then it changes, and at the end of the day they still can use it, but the governance kind of changed, and so yeah. Well, a couple of nice announcements, I guess. Now, on the brighter side, maybe for some people, maybe for some people not brighter. I don't know if you heard about a company CodeFresh. Was like one of the contributors to Argo CD project. They had a nice solution around Argo CD. They've been acquired by a company called Octopus Deploy. Octopus kind of, I don't know if anybody uses Octopus here. Okay, is it good, bad? Okay, okay. Yeah, so basically they joined the forces and there's a new company right now. So I think Octopus was more focused on in general infrastructure and enterprise application deployment, and CodeFresh kind of adds the Argo CD capability at scale for them. Sad news from a company called Weaveworks. I don't know if you remember this company. Recently they closed the doors because they run out of the funding. Talking about, you know, running a successful open source company. So they had another issue is that we don't know all the story, but I've heard people, there's many companies tried to buy them out, but something didn't work out. Most importantly for us is GitOps Flux project, because Weaveworks was the main contributor to Flux, and all developers who contributed to Flux, the main ones, they were from this company. And obviously they lost the jobs one day, and then like there was a big question mark what's going to happen to Flux. So the good news is that a company called Crossplane took all of the employees from Weaveworks who worked on the Flux, and they actually trying to build better governance now so they don't depend on one single company. And if you're using Flux, please don't be worried. Everything is good. I spoke to the maintainer. I think they're more happier than they would have been acquired by another company who had bigger plans to use Flux as a like enterprise solution for everything, sort of say. So either using Argo CD or Flux, I think they still both valid GitOps project, and you should continue using it without any concern. And you can actually, you know, work with this community. Yes. I personally feel from what I've seen at Kubecon, yeah, he was asking like, which of the project has bigger community behind it in terms of contribution or usage? Yeah, I think my personal opinion, again, don't judge me. I think Argo CD is a bit more popular these days, maybe because it's a UI driven as well, and you know some developers like to see, you know, what's the, yeah. I don't want to like compare both, but I personally feel more like I would use more Flux to deploy configuration across Kubernetes clusters, maybe deploy some policies, for example, whereas I would use more Argo CD, potentially deploy applications and more developer friendly, maybe some way to integrate in your developer IDP portal or something like that. So like, I think it's more user friendly. And another reason I liked Argo is because it was developed by the company that doesn't make business with Argo CD. So Intuit doesn't have anything to do with the business of Argo. And like any other company can build solution, let's say, if cloud provider decide to make a product with Argo CD, or if there is another company wants to start a startup around Argo CD, it's there to grab. Whereas Flux was like Weaveworks thing. And this is going to change now. So maybe this is going to help Flux also to grow in the future. So both good projects. I think Flux maybe at some cases even more scalable than Argo CD. But you know, I don't want to compare. Like I have a feeling Argo CDs have an edge these days. Couple of CNCF news. So KubeCon North America is going to happen very soon at Salt Lake City. Any people trying to go there or submit CFP, I think this is a good time. So CFP closes June 9. And we also already have a next KubeCon in London. It's going to be 1st April 2025. So if you love London, you want to visit Chelsea game or something, like this is a good opportunity to have both a visiting conference and see some good football. And then we actually have just heard all the announcement about all the next KubeCon. So after that, KubeCon EU 2026 is going to be in Amsterdam. KubeCon North America 2025 is going to be in Atlanta. and then another Kubecon is going to be in Los Angeles. So you can now start planning your travels and pick the battles where you want to go. I personally want to go to all of them, but I think I might skip the next this one, the Salt Lake City. I don't know. But yeah, but not. I think like the Kubecon is not for everybody, and unfortunately, none of the Kubecons in Canada, right? If you have a travel bans with the companies right now restricting the budget. We actually have a local event in Toronto, in Canada, hoping maybe one day we can organize something like that in Montreal. It's called Cube Huddle Toronto. We had it last year in May. It went pretty well. And then we have another Cube Huddle that is happening pretty soon in May 7th. So if you want to register, we have a code for you. You can use it and get 30% discount. Ian is going to be one of the speakers. There's a crazy lineup there, but this time it's going to be one-day event, one track, so everybody can kind of huddle up. So I'm looking forward to go there. Last year I was a keynote speaker. This year I'm just going to go enjoy and meet the community and talk to people. So I'm very excited about it. So please bookmark, and then if we'll also share in the Slack the QR code and the discount. Any questions? All right. So today we're already like doing our event here at iSpeed. We already have plans for the next events. Our next meetup is going to be at OVH Cloud, May 8th. So we'll have some people from Cube Huddle actually traveling from Toronto to Montreal, but we're gonna also look for local speakers. So if you wanna present, please let us know. And then the next meetup we're planning in early June is gonna be Kubernetes 10-year birthday anniversary party. So if you're interested as well to speak or help us, let us know. So we're very excited about this nice dates. And like, we apologize that we didn't have an event for almost 5 months. I think we're gonna try to catch up now and do it more often. Not yet. We're gonna post them like right after. A few CNCF updates on the projects. We recently incubated a Streamzy project. I don't know if you're familiar with Streamzy. It's like an operator to deploy Apache Kafka on Kubernetes cluster. So it's been incubated. Open feature, this is like kind of new project for me. I actually haven't heard, but it was also incubated. Allows you to use feature toggles and other things with Kubernetes API. Cloud events also has been graduated. This is very important project for to having a standard around cloud native events. So have like its own API, and then it's going to be like a standard project. And then very exciting news recently, Cilium has been graduated. Any users of Cilium in production? What? It's like only 2. Anybody else? No, I just I checked Google Next. There's a Google conference, and Shopify will be presenting how they migrated from Calico to Cilium. So it's big clusters, and they're using it in production. So it's I think becoming very mature solution, and yeah, like it's open source. Maybe I didn't let you guys know, but actually, company behind Cilium, Isovalent, has been acquired by Cisco. So it was like kind of interesting news, but it looks like everything is good. Spoke to maintainers, people who were Isovalent, they like still kind of operate like a separate company. But you know, this is the like one of the things. Yes, I hope so. All right, and most importantly, round of applause for Falco project is being graduated. So we have folks from SysDig who's going to talk about Falco today, but very excited. It's been a long journey for this project. They didn't want to like push it to graduation right away. It took some time, but there's a lot of users, big adoption, even in Canada, that using Falco project. And then I think Falco is like continuing its maturity and adding more functionality, something that SysDig will share today from the open source perspective. All right, finally, you guys bored listening me? I want to actually have a quick round of applause for our next round of speaker panelists. So we'll have Ian Crosby from CloudOps CTO. Please welcome. And we have Sonia as well. And we want to just quickly cover the KubeCon recap and just ask audience like if you have any questions about it. But just also we have our Alex who is going to help us to run this panel. But before that, just want to share a couple of numbers. KubeCon Paris was the largest KubeCon ever. 12,000 people. That's what I've been told. We didn't get like the final like confirmation of that, but that was supposed to be the largest so far. I think the San Diego was like close to that number. There's actually pretty good attendance from North America. Obviously, most of the people I saw was German for some reason, and a lot of French folks and Poland. But I don't know. Like I think it was pretty much everybody, like even Italians. Like so, it was well attended. As you can see as well, there was over 2,500 CFPs to the event, and acceptance rates was like below 10%, right? So it's very hard to get accepted. And so a lot of people kind of brokenhearted because they put their CFPs, but they were not accepted. Everybody was kind of sad about it, but there's ways to get into KubeCon without going to main conference. There's co-located events, there's KubeRegex, so we can share about this more. And yeah, most represent country, France, Germany, yeah, USA. I think it's about right. But we had a group of folks from Canada, so we want to share a bit our experience, if you don't mind.
All right. Well, first of all, we'll start with introductions. Just a few words about yourself, and I want to know, especially if it's your first KubeCon, or if, like Archie, you attended all of them.
Yeah, my name is Archie. I'm CNCF ambassador, but I also work at Google Cloud. It's been 5 years. Before I was actually working at CloudOps as well, so some good memories from there. And yeah, I don't know, I lost the count. I think it's 10 or 11, but like for me, KubeCon is like essential because I'm trying to understand what is happening with the community and what we can bring to this meetup, like interesting topics, interesting presenters and stuff like that.
Hi, I'm Sonia, software developer at Ivado Labs, and software developer, data engineer, ML engineer, whatever you want to call it. And I'm more of an end user, and I was also very interested in hearing about the ML part in the KubeCon. It's huge this year.
Yeah, I'm Ian Crosby. I work at CloudOps. I've been to most of the KubeCons, maybe. I think most interesting, I was at the first KubeCon EU in London like 8 years ago, which was like, I don't know, like 200 people maybe. So 200 to 12,000 was pretty crazy to see the difference in the growth.
Yeah, mine was Seattle. I think it was even smaller.
Yeah, my first KubeCon was Detroit, so 1.5 years ago. So I'm pretty new.
Nice. So you leave Montreal, you leave Canada, you land in Paris, you're jet lagged. I guess you have plans. What do you do?
Yeah, so we actually, I was with my co-organizer from Quebec City, Sebastian. We both were not paid by the companies to go there, so we had a place to stay in Boulogne, in Bois de Boulogne. I don't know if you know this place, but we went around see the sightseeings. But like I think the first thing we went is a Regex conference, and this is like a good tradition for us. When we go to KubeCon, we try to go to Regex. A lot of times it's one of our friends speaking there. It's people who are rejected from the main conference. They go there, and it's a very small conference. It was like 100 people-ish, and you have a chance to see everybody, like very intimate, and like all of the people are very like involved in like CNCF or like in this area. So like it was this was like what I've spent my first days at Paris.
Yeah, I also wanted to go to Rejects, but it's a really small conference, so I couldn't get any tickets. So I just took a vacation 1 year, 1 week in Paris before the conference. Yeah.
Rejected from rejects. That's tough. 3 days of a conference is enough for me. So I've heard great things about rejects. I didn't go. 3 days is enough. So yeah, I just got in, and you don't want to hear this, but the weather was much nicer over there, so I enjoyed that.
Yeah, we had a backup plan actually. We're supposed to go to Versailles. We didn't have tickets for Regex. So we said if we're gonna get rejected from Regex, we go to Versailles, but at the end we made it through.
You're lucky. All right. Jan, you mentioned, 3 days of conference is enough conferencing. Whenever I had the chance to attend Kubecon, I always enjoyed the co-located events that happened the day prior. Were there any cool events this time? Did you attend any of them?
3 days is enough. I didn't. There were some really cool ones. Would have liked to attend, and especially Platform Con Day, platform engineering was definitely a big theme, and also related to kind of the whole like open source discussions. There was a whole Open Tofu Day. Again, didn't go, but sounded interesting.
Yeah, it was really hard to choose. Well, there was this Istio Day and there was also Argo Day, but I actually decided to go to Soft App Developer Con, sorry. That was it was an interesting experience because as a developer, when you go to KubeCon, you often hear about this platform engineering thing. So as a developer, you might feel like you're kind of an outsider coming in. So that was a really good experience for me.
Yeah, so for the folks never traveled or planning to travel to KubeCon, there was a change recently. So previously, when you go to KubeCon, you have to buy a ticket for one of the co-located events. Now there is a change. If you purchase like co-located events pass, you can go to any of them. And so you have this dilemma. There's like 20 co-located events, and I was like, which one I should go? So I had the same experience, and I was like fear of missing out. But all of the talks are recorded, so you can go ahead and just find them on YouTube right now. So it was more important for me to connect with people I'm working on different projects. So I spent most of my time with the Thanos days and observability days. It was really a good organized days. I went a couple of talks to see the platform engineering and backstage, and I was like, kind of I didn't like it as much, but like I think I was very excited that there's a new movement and new conference created around those technologies, which is like very hot, I would say. And then obviously like I saw Argo CD and Istio like had a very good attendance, but like I find like at least if you go there, you're gonna find people that in your interests. So if I went to a Thanos Day, obviously all of them were Thanos maintainers or Thanos end users. So you can spend a good amount of time just talking to them about the problems or good stories and stuff like that. So yeah.
Nice. So 3 days of conference, there's a lot of material, lots of tracks. A lot of you mentioned platform engineering, developer experience. What's the main theme, the highlight of the conference in one word or one sentence, maybe?
ML. Well, there was especially first day. I think it was the second day during the keynotes that. Well, I think some people think that they're trying to learn something about ML, but they don't really know how it's going to be useful for you. So in the conference, in all of the keynotes were ML, and we saw people like standing up and leave. So maybe even too much, I would say.
Yeah, I mean that was definitely the biggest kind of theme was the AI. They're really trying to make CNCF kind of the home for where you run, and Kubernetes as like a thing for running workloads. I don't know if it's like trying to predict the future or just trying to stay relevant, but we'll see. They even released like a cloud native AI white paper kind of in simultaneous with it. So it's interesting. It'll be see where it goes. The one other theme, which I think on the second day was bigger in the keynotes, which I expected to see a little bit more about, was sustainability. There's like the sustainability tag and the talks around more efficiency and carbon utilization in the cloud. There was some good talks. There was different vendors pitching it. There was, like I mentioned, some of the keynotes. So it's nice to see it's still a trend that's growing. I think probably more so in the EU than the North American version, but it's getting stronger.
Yeah, I agree with the above. Like, I think right now in North America we have this trend about LLM and AI. Like, and I think CNCF didn't really maybe understand the people in Europe are still like in Kubernetes world, and then like they came to this conference and they're like, everything was about LLM and AI. Like, so like it was a bit shocking. Like I felt like I'm an AI conference, not at KubeCon. First day. Second day was another like disappointment. Like it was a lot of sponsors talk, but like third day was like finally they talked about like Kubernetes community, Kubernetes project updates. They talk about the WASM and crossplane and the project for Gateway API is finally V1 now. So like there's obviously like something like people really came to conference to hear about. It was all like in the last day when people already, some of them left, I think. But I think it was kind of lesson for CNCF in a sense, like they need to like maybe have more European people as the keynoters, like so that they fill the audience pretty well. But I think the goal was for CNCF is to position, you know, maybe for the home of the new projects like Olama, or, you know, they want to make sure that CNCF is not left out from this new era or like this new thing. Like I think, you know, Solomon Hayek, he's from France, right? He was on stage and he was talking about Docker and then how Kubernetes took over the world from them. And then he's like saying like, well, now it's like AI's time, you know, like this is like how things are moving fast. So it was like, it was very like accurate. And I think CNCF is trying to make sure that we are home for these open source LLM projects, and we'll continue this good, you know, line of being a very well governed place for these projects to grow in the future. So I hope we get better on this and we'll have less LLM. But even today, we have a speaker that is going to talk about LLM because it's so hot right now.
Yeah, it is a hot topic. Let's talk about boot crawl. I'm sure you had a chance to navigate the halls of the conference center, maybe avoided the bigger booths, and discovered some cool new projects, some underground tech. Anything new? Anything cool?
Well, I don't know if it's cool, but well, I discovered Dapper like a lot. So, um, it wasn't really in the booths, but like everywhere around in the conference, you would hear about this inner loop and outer loop and how you want to make it more like less like these two loops, development loop, more similar to each other. And like it seems that the Dapper was the solution. Maybe I'm a bit behind because I heard it also in Chicago or Detroit, but you know, it's really getting on.
Yeah, I think there was a lot of vendors there pitching of the whole platform engineering bandwagon, I guess. A lot of others in terms of like optimization and cloud costs reductions. Some cool things like Cast AI, they're not that small, but it was pretty interesting, their kind of solutions of how they optimize Kubernetes workloads. Kubecost was neat. They added something to actually measure carbon intensity along with the cost. So it was, again, interesting to see that. And then WASM, I think you mentioned was another big theme. So like Spin was a project I wasn't super aware of. Does some interesting stuff for building like WASM serverless stuff.
Yeah, I actually, when there's a conference, like it's my tradition, I don't go to the tech talks. During the KubeCon itself, I spend all the time at the booth trying to find sponsors and speakers. But like I noticed, like this time there was a lot of new companies that provides developer portals, platform engineering tools like Humanitech, Port, Cortex, like those are like kind of new kids on the block. And then like a lot of new security companies. I think like the difference that I see right now is that before it was like most Kubernetes companies in security, or actually most security companies, they were just talking about Kubernetes security, container security, but now like there's a cloud security in the mix. There's like so many things, how to, use the path attack simulation. So like there's many, and most of these companies from Israel, but like it's just been like surprising for me to see how many companies we have right now in security. So hopefully we're going to be well covered right now. Just need to make a good choice.
Nice. And how's the nightlife in Paris? Any cool parties or extracurricular activities?
No comment.
You're not gonna see the video of the one CNCF guy doing a DJ at the Paris party.
Yeah, so Sebastian is our organizer from Quebec City. He was DJing at the Humanitech party. Yeah, there was another naked lady there, but like I kind of removed it from the picture. But I mean, it's just, I think Paris is amazing. Like, I think one of the reason I went there is just I want to really see the Paris. I just missed Europe, and like it was, just great to see and have this experience of Paris, and like the events was amazing.
That's awesome. Thanks for sharing all of your amazing stories. Don't know if people have questions, maybe, or experiences to share.
What do you prefer? Kubecon North America, CNCF North America, or CNCF Europe?
If the question was about the KubeCon, well, if I had to compare with Chicago, I think in Paris there were fewer cloud, like if you're a beginner in this world, you go to this track that's called Cloud Native Novice. And I found that in Paris, those were, even though they were named novice, they were kind of specialized. So I had a hard time finding some interesting things. So in Chicago, there were so many really good talks for beginners, whatever. So I preferred that one.
Yeah, I actually don't want to divide Europe, North America. I think it's more about like how well they choose the venue. Like I think in Paris, it was not the great place for the venue because it was outside of Paris itself. So like most of the people who are not familiar how to take metro, they might even didn't feel the experience because like the food there, okay, there was croissants, but like most of the fun time we had outside of the conference, like we really went out and like go crazy. Like for example, Amsterdam was much better in this sense, and I think maybe because there's some financial problems in many companies, there's much less parties right now. So like in Amsterdam, we just like banana, like we were like, I couldn't go third day already like to the anything, but like I think it was less of that this year. But I think it's like it's really depend on the place. But I prefer to go North America simply because it's closer, and also like the I think there's more people from the upstream community, developers, like and there's more speakers from like I don't know. I find this better quality, easier access to like everything, like so. But I love Europe as well, so like it's both good, I think.
Yeah, I mean, if you want to go talk to maintainers, it's not. KubeCon EU is way more fun. So if you have a choice, go to that one.
Cool, thanks. I think we're good. Thank you so much. Thank you, Ian. Sonia, anybody else who went? Actually, I should have asked. Anybody? No. Okay. Okay. So with that, we want to invite our first speaker, Chris Grell. Please welcome on stage. So he's gonna talk about like very old things about LLM and AI. Yeah. All right.
All right. All right. Hello. So my name is Chris Gruhl. I am a solutions architect at Achilles. I've been here for almost 3 years now. And we'll get into what Achilles does, but it's secrets management, secrets orchestration, right? And I've been here for almost 3 years. Before that, I was at a DevOps company for about 1.5 years. And then before that, I was at the Home Depot for about 14 years. So I lived through digital transformation, migration to the cloud, containerization, all of that. So I'm starting off by talking about the different things that we're going to talk about today, right? We're going to talk about the challenge that we tried to fix with this tool. We're going to talk about our goal, what we're trying to do, all these things on here, you know, tool selection, how we're able to do. Most importantly is, you know, the integration of human insights, right? Human in the loop. Developing conversational agents, and we're going to see the installer in action, as long as the demo gods are on our side. We're going to be, you know, talking about the different lessons and future directions, and we'll do some Q&A. So this is the Achilles Gateway. Now, the reason this is important is because Achilles is a secrets management SaaS. Now that almost sounds like ridiculous if you think about it, right? Secrets management SaaS. Well, that's because we have this, you know, DFC technology, distributed fragments, and basically the local gateway, your local gateway that you deploy into a Kubernetes cluster, a stateless Docker container, it's all you talk to, right? Everything in that local network, everything had connectivity just talks to their local gateway, right? They're in the cloud, they're going to talk to their gateway. They're on-prem, they're going to talk to their gateway. And every gateway just requires an outgoing network connection to the SaaS. I promise this is all important for this talk, okay? So we're going to deploy this gateway, right, with a Helm chart into a Kubernetes cluster. That is the default. That is the recommended best practice, because then you get horizontal pod auto scaling, and it's just a stateless Docker container, right? So everybody just talks to their local gateway, but every gateway in every environment is all connected by the SaaS, which means you don't have to have holes in the firewall. You don't have to have VPC peering, right? Everybody just talks to their local gateway, but you can get secrets from another gateway. So I could be in the cloud asking my local gateway, and it would get a secret from another gateway. Fine, okay? Which means the gateway is critical. We gotta have the gateway, but it's all we need. All we need is the gateway, and it's a stateless Docker container. So we have options, right? That gateway needs to have that outgoing connection, and it needs to authenticate. Now, you don't want to authenticate with static credentials, right? Nobody wants to authenticate with static credentials. Yes, it's the easy way to do it, but it's not what you want to do in production. You want to have some kind of federated identity. And so that's part of what we need to do with the gateway. We need to create an authentication method. So if we're in GCP, we need to create a GCP authentication method so that the gateway can authenticate just using its existing cloud identity. If we're in Azure, we need to authenticate with an Azure authentication method, cloud identity. Same thing with AWS. Same thing even with on-prem, right? We've got different tools for different functions. None of that's important right now. What's important is we need the gateway itself. We need to create the appropriate auth method for the environment that we are in. Right? Right now, it's kind of a manual process. Like the first step of a POC, you know, we're going to create the appropriate gateway authentication method, and then we're going to deploy the Helm chart. Cool. Whole process takes 20, 30 minutes. Not a big deal, right? The hardest part is getting people who have the right access to the different cloud providers. So the idea here, we're like, well, you know, what if we can use tools? What if we can start creating agentic behavior? We say we're going to create an autonomous entity that can perform tasks on its own. What's an agent, right? It's just something that calls functions. That's it. It just calls functions, right? And we just call them a fancy name. We're going to call it tools, right? So the agent just calls the appropriate tool that it needs. And we then give it a list of tools, and we give it a task of what we want it to do. And the agent does the work. So how do we do this? Well, I had never, right? I've coded in JavaScript, I've coded in Golang, I've coded in Java, I've coded in a bunch of things. I have never in my life coded in Python, right? Never. So what I decided to do was I'm going to create a pair programmer. So I went to OpenAI. I went to platform.openai, created an account. I went to the assistants API, right? And created an assistant. Now, if we look at the assistant, I still got it in here, Project Heimdall Expert, right? Inside here, I've given it instructions of everything that I want to do. I don't know how to write Python. I don't know how to write LangChain. I don't know how to do any of that stuff at the time that I started. I've learned a lot since then. But at the time, so what I did is I just went in here and created an assistant, and then I gave it all the documentation for all the different things that I wanted to work with. LangChain, LangGraph, Streamlit, right? Every little thing that I thought I needed documentation and help on. And then I created a thread, right? And the nice thing about this is that you can create this thread, and we can see, it's a little hard to see, but we've got about 2.8 million tokens that that has gone through all of ChatGPT, this entire history of everything that I'm doing. We could see stuff in here where it's like coming up with the different, tasks about it because it's the expert. It's been walking me through piece by piece on how to do things. And so it will tell me, hey, here's a code example. Here's you're going to go. And often these code examples, it doesn't actually fill in the details. We'll get to that, how we're able to get around that problem. Right? This is like pseudocode in here where it's like, hey, you should just fill something in, do the right thing in here. Great. So we take this as a start, what we get out of the assistant, right? And then where things really took off is I started using the Cursor IDE. Now, I don't know if you guys are familiar with the Cursor IDE at all, but it's pretty great. Now I'm gonna have to kill those APIs at ENV. That's recorded, too late. I have to reset them all, it's fine. But here, right, we've got the Cursor IDE because the nice thing about the Cursor IDE is whatever thing that I'm trying to look at, whatever function I'm trying to do, whatever I'm trying to do, I can simply just, create a little chat on it and ask it. And, ask how I can do something. And it's all going to be using ChatGPT under the hood, but it has context. Right? It has the context of the code. It has the context of the libraries. The function calls out to this other thing, and it knows all of that context, and it adds it all. So a browser with an IDE with deep integration, you can do a lot with that, right? I'm sharing not the whole screen. So we're going to share the whole screen, right? So this was what really got me going really fast. Is I can start, giving it the different functions. I can start creating the different classes. I can do all this, and I'm just, ChatGPT writes about 90% of it, right? I know what I'm doing, and I know if it's doing something stupid, so I can at least, say that's not right. That, fix this, and it's an iterative partnership, right? This method of learning can work for anything. Assistance API. Long-term threads, whatever you're trying to learn, whatever you're trying to do, take advantage of the tools that are out there, right? So we create the assistant, we've got our thread, we're chugging along, and we've done a ton of work, right? We're getting the agent, right? We're getting the code structure for how to make the agent. We've got LangChain, LangGraph. It wasn't until LangGraph came about that made all this possible, by the way. And for those of you who have ever worked with any of the, LangChain, right? LangChain is an abstraction, right? It's going to let you just deal with the code. It's going to put an abstraction around dealing with the actual LLMs, okay? But where LangChain really comes in handy is the ability to connect to all these different things, connect to documents, connect to databases, connect to APIs, right? All those things are what make LangChain really great. So we start playing around with LangChain. The problem is you can't create cycles. You can't, with LangChain, it's going to go from start, and it's going to go all the way down to the end, and then that's it. But with LangGraph, you're still running those lang chains, but you come back to it. It's a graph. And you can decide, you know, were we successful? No, we need to run a tool. So now we run a tool. Get the results of that tool. Are we successful? Yes. Move on to the next thing that we have to do, right? On down the list. And you let the agent decide what it needs to do based on what you're trying to do. And you're doing that with natural language. And the functions, you just have to be smart about the functions. You want to give it as simple as possible. Literally think, I'm making this function for an idiot who can only press a button with a mallet, right? That's it. That's all. We don't want any complexities. We want to minimize the complexities completely and just make it so that it's just simple inputs, simple outputs, because it's not very smart. Smart enough, but not very smart. Where it gets smarter is with this cycle, right? The agentic. It can make mistakes. Who cares? It'll get it on the next try. And better than that, it'll get the context, the history of the mistakes that it made on the next try. And it could do better, just like a brand spanking new developer, right? That's what this is, right? These agents are basically fresh out of college, you know, kids who got a lot of knowledge, but not a lot of practical experience, right? And so LangChain gives us this abstraction so that we can deal with the complexities of interacting with different language models and stuff like that. And then LangGraph gives you that cyclical workflow. And then the next big thing is the human in the loop, right? We want to make sure that it's, again, a partnership because it's dumb, right? And so that's where we create this chat interface. Now, we started off when I was playing around with this, the idea was that we were going to create this installer, right? All the marketplaces, all, you know, AWS, Azure, GCP, they've all got, you know, Helm charts that you can deploy, and there you go, you're in the marketplace. You got to get approved and everything like that. And then once you've deployed it into the Kubernetes cluster, you're good to go. So that was the point of this, right? Create an installer that had a chat interface. And you just tell it what you want to do. Now, we started with Streamlit, which is pretty great, by the way. Streamlit is a Python user interface, works pretty good, but it wasn't built for this. Chainlit, on the other hand, was built for this. It was built specifically for this, for interacting with large language models, right? And so that's what you're going to see in the demo, is that we're using Chainlit to give us that interaction with the large language models to create a chat agent executor, okay? Now, we need to integrate the human insights, right? We need that because the agent might not have everything it needs. So one of the tools at its disposal is human, literally, human tool. You say, hey, you know what? If you don't know what to do or you're stuck on a problem, ask the human. And it'll create a question and it'll ask the human. Or it'll say, you need to help me because I have nothing. I have no idea what to do here, right? And so it can do that. Now, how much help you can give is a whole nother story. And we'll talk in the future section about the different types of help that we want to give it. But for now, this is what you can do, right? We want to create that human insight. We want to give that human in the loop and keep the human in the loop. So we build the conversational agent, right? We make it so that it has a list of tools, like things like what we talked about. We need to figure out what are the things we need to do. We need to figure out, do we have permissions to deploy into this Kubernetes cluster? Well, how do we figure that out? Well, we're in the cluster. We can call out to the cluster's internal API endpoints. Yay, cool, that'll work. Now, once we've called out the internal endpoints, we can figure out what namespace we're in. We can literally just examine the Kubernetes service account JOT, figure out what namespace we're in, figure out what Kubernetes service account we're in. And then we can take that information and send it to the cluster itself and say, hey, am I allowed to deploy? Am I allowed to create pods? Am I allowed to create stateful sets? Am I allowed to create deployments? Am I allowed to create secrets? Am I allowed to do all the things I need to do to deploy this thing? And so that's just another tool. Can I deploy? And then another one saying, which cloud provider am I in? And then another one saying, oh, I'm in the GCP cloud method. Cool, I'm going to create the auth method for that, or Azure, or AWS, on down the list, or fall back to API key or universal identity, right? So the point there is that under the hood, we're just using the Achilles SDK on these dumb functions. We want the functions as dumb as possible. Again, just a stupid person pressing a button with a mallet, right? That's it. Just keep it simple as possible. Minimize the number of inputs for the agent, right? But also, I'm not the one doing it, right? The large language model isn't here. Now, it could be, possibly. I don't know. I haven't played around with Ollama, and theoretically, it could run an Ollama server in there, but let's stick to what we have, the easy way, which is OpenAI. I do not want the Achilles token going back to OpenAI. That would be bad, right? Because it could end up in some training data somewhere. They say they don't do that, but So we want the SDK to just get populated, right? The environment variable to get populated, and we'll show how we're doing that in the code, right? And then it just runs, right? The environment variable is populated with the Achilles token, and then it just runs. It can create the authentication method. It can validate the token. It can do all the things that it needs to do. So let's take a look. And hopefully it works. It should work. So this is Heimdall. What's that? Make it bigger? Sure, let's make it really big. Is that good? Yeah, that's good. All right, so this is Heimdall. This is the user interface, the standard user interface for Chainlit, okay? Now what I'm gonna do is I am going to authenticate to my Achilles account. And this would be like the first thing that someone does. They're going to authenticate to the Achilles account. So I'm going to authenticate using my Okta SAML. And I'm in. This possibly could be the very first thing someone does. And I'm going to come in here and I'm going to click copy token. Great, I've got my token. Now I'm going to go into Heimdall and I'm going to go down here to settings and I'm going to take this token and I'm going to paste it in. So now the user interface has the token and it's going to set the environment variable for the code, for the SDK. But first it validated it, right? Validate it. We've got 11 hours, 59 minutes. Would you like to approve the scanning of the environment and install the Achilles gateway? We've turned a 20-minute operation into pressing a button. So now we press the button and it starts working. It gets the pod namespace and service account. It checks to make sure it can deploy into the namespace. It checks to see what cloud service provider is in. It figures out that we're in GCP, so it created the GCP auth method. It now has the auth method ID, right, the access ID, and it's now going to start deploying the gateway. If we look inside the Kubernetes cluster using K9S, and we're going to make this bigger too, we can see it's already starting to deploy, right? We've got container creating, we've got running. This is running, we've got one up, and we're waiting on this one. And now it's up. And at least it will be up. It's running now. It just needs to finish the validation. And we're good. We come back over here. The Helm chart has been deployed. And now it returns. The Helm chart, Keyless Gateway Helm chart has been successfully deployed in the namespace using the GCP authentication method. And here's the details. All right? All of it. We're taking out the complexities, right? And making it so it's a single button to create a gateway. Because remember, the gateway is everything, right? We've got the ability to do zero knowledge encryption. What do? You install the customer fragment for the zero knowledge encryption into the gateway. You want to do dynamic secrets, done by the gateway. Rotated secrets, done by the gateway, right? The gateway, though, is a stateless Docker container. So we're deploying that. This is the key. Once we've done this, we're halfway there, right? And this is what we're doing here is we're simplifying the process, right? We're simplifying the process so that it's Anybody can do it. Now, but we're also showing how you can do it too, right? You could create your own AI assistant to help you work on anything that you want to work on, right? Any one of the open source tools that just got promoted, right? Pick one that you want to work with, create an agent, literally go into all the documentation, concatenate all the documentations, public documentation, those markdowns. LLMs, by the way, are really good at reading markdown. So concatenate it all. Get all that documentation in one file, and then give that name, right? Make sure you name the file appropriately, because the ChatGPT agent, the assistant, can only see the name of the file to know which file it needs to look at. So name the file appropriately, and then start asking questions. It will know to look up in the retrieval when it needs to. And so it will use that to help you, because it can read it all in a fraction of a second. Well, seconds, a couple seconds, right? And then especially, often it will give you like, fill in the implementation code here. Cool. Copy that code out into the Cursor IDE and tell Cursor, hey, you've got extra context. You know that this other code really relates to these libraries and these functions, right? And everything that's available on here. So go ahead and fill this out. And you just use the chat interface, or you just use the edit interface, and you tell it what you want it to do, right? So out of all of this, I think I wrote maybe 5% of it. But that's because I've got the experience to know what's right and what's wrong. However, even if you don't have that experience of what's right and what's wrong, you're getting pretty close. And if you start to have it actually generating tests as well, why not? Right? Then you can feel more confident about the code, even if you're not 100% sure. But for one, don't waste time on dead ends solutions not suited for purpose. This one is completely relating back to Streamlit. I kid you not, I spent like a month and a half trying to get that thing to work right. Could not do it. So I was trying to fit a square peg in a round hole, and for some reason it didn't want to go in. No idea why. But what I have here has a lot of other potential too, right? It's just firing off API calls. It's just running functions. So have more functions. Have it deploy the Kubernetes secrets injector, or it's already in the cluster. It's already in the cluster, so what if we give it permission to see what cluster resource definitions, right? CRDs, right? Custom resource definitions. And we see inside there that there are resource definitions for external secrets operator. Well, we've got an integration with external secrets operator. We can literally offer that after we've scanned and we've checked. Hey, you want us to install that? We can literally hook it up, wire it up for you. We can create Kubernetes authentication. We could do all kinds of things. We could see the Nginx is installed in here. Maybe we create Nginx ingress or offer to create Nginx ingress. It depends on the permissions that you want to give it. Or, I do a lot of POCs for a lot of companies. This is almost a dream. What if I could make a self-service POC? You could just add it into your environment and say, yeah, that's awesome, but I want to see it work with MySQL, and it could deploy a MySQL server and then wire it up into a keyless for automatic credential rotation, and then wire it up into keyless for automatic dynamic secrets, just-in-time least privileged dynamic secrets. And then just there, it's done. You've got it out of the box, already set up for you. And then especially incorporate all the public Achilles documentations and then make it so that it can ask questions about them. Why not? Right? RAG is not that complicated. We can ingest all those documents, put them into an in-memory vector store, and just have the agent have access to them. Cosine similarity searches, right? That's what RAG is, just math, simple math. Okay, not simple, but you get the idea, right? So I want to show a couple of things. One, this repo, Achilles community, Heimdall, this is it. This is the AI-powered Kubernetes Helm chart deployment. This is public. Anybody can see this. Anybody can access this. You can see how it works, right? We've got documentation in here. But if we look at the main thing, like how are we doing on time? Are we good to go for this a little bit? All right, cool. So if we come in here and take a look, right, it all stems here. We've got Chainlit app, right? And in here, we're using LangChain, we're using, we're using LangChain, we're using LangGraph, we're using a bunch of stuff in here, right? We've got our human input tool that is tied into, right, Chainlit. So it's asking a user message. We've got our deploy gateway command, right? Everything is in here so you can see how it's all set up and how we're connecting to everything. We can see here how we're populating the Achilles token. Once they give us the Achilles token, we're populating the environment variable, right? All that's in here. And then, but where things get interesting is in this section right here, on chat start. That's where the thing is starting up. And so now what we're going to do is create a bunch of tools, right? A tool is just something that's going to run a function. So we've got, the first thing it did was get pod namespace and service account extractor. Well, what's it doing there? It's literally just calling out, right? It's calling out to this function. And inside that function, right, what that's doing is literally just calling out, right? It's extracting the token. Remember, this is running inside the Kubernetes cluster. It's got the JOT token right there. So we just read it, and we parse it, and we get a service account name, and we get a namespace, and now we have that information. That's easy, right? No problem. And then after that, we got other tools, right? And all the individual tools is just simple functions. And then we put them all together, right? We've got a human input tool. We've got a calculator because LLMs are crap at math. So we need to give it a way to do simple math if necessary. Believe it or not, that's quite useful. We figure out what namespace we're in. Can I deploy? What's also interesting in these tools is that we're giving them we're giving them descriptions. This is the most important, right? The name of the tool is important because it's telling it how to use it. And then it can look at the description and see detailed information about how to use it, right? If the name exists, another name should be chosen. On this one, right? Check if a keyless auth method exists. That would be a different function, right? And so each of these functions are available to the agent. And then all we need to do, I know it sounds like all we need to do, but right here, this is the call model. And so this, we've got a graph over here where we've got the agent, and it's I kid you not, it's a 2-node graph. We start on agent, and the agent knows the different tools that it has available, and then it calls a tool. And then the agent decides, do I need to go back to the agent, or are we done? That's it. So agent to action, action to agent, and then the agent decides if we're done. Rinse and repeat over and over and over again until it's done everything. But what's great, especially about LangChain and LangGraph, is the ability to monitor how all this is why up here I've got this LangChain tracing, LangChain API key, LangChain project, because I have the ability through Langsmith to literally look at all the interactions that we just did. I can see right here, how much did it cost me to do this, right? We're gonna zoom it, make it a little bigger. It costs 6,553 tokens, which is 0.3 of a cent in US currency, 0.3 of a cent. That's how much it costs to deploy that gateway into the cluster because it ran those functions. It did all those capabilities, right? So, like I said, we're planning on adding documentation for the RAG so that when you get stuck, you can literally just ask questions. We'll have a router that says, is this a documentation question or are we trying to install? Are we trying to upgrade? Are we trying to make changes to the existing gateway? Maybe we want to alter the Helm chart, right? That's all future functionality. We want to be able to deploy other things like the Kubernetes secrets injector or external secrets operator or anything else that we need to do like that, like my dream of the self-service POC, right? And so then once you've done that, once you've done the call model and the call tools and you get to the end and you're done, then it's just reading it, just reading the output, reading the data, right? Right. And then inside here, inside Heimdall, we're showing under the deployment, we've got a whole bunch of different manifests, and we've got a customization YAML file for deploying it into the cluster, right? With a whole bunch of different options for cluster role binding, for regular role binding, for cluster issuer, whatever you want to do, it's all in there. And scaffold for easy initial deployment, but also the ability to have that, automatically retry if you need to. And if you all haven't played with Mirror D is pretty awesome for this exact thing. Like the ability to have it so that I'm running here, the code is actually executing inside the Kubernetes cluster, but I get full debugging and tracing from here, right? That's what Mirror D gives you. It's pretty nice, right? The ability to manipulate the code and have it just regenerate, rework. So Mirror D, Heimdall, Chainlit, and the deployments. All right. Thank you.
Steve, thanks for coming in.
Thanks, everyone. All right, so quick intro. My name is Steve Caron. I'm a staff solution engineer at Grafana Labs. I've been there in the company for about 2 years. I'm based in Montreal area. But I've been working in the observability space for about, hold on a second. Why, hold on, why is not full? Hold on a second. Is this updating? Sorry about that. So problem with the Zoom. All right, so yeah, so I'm here to present about an introduction to continuous profiling and also to Grafana Pyroscope. So I'll get started. I'll kick off with a little story. So the story is once upon a time, there was 3 little brothers living in the CNCF land. They were nicknamed M, L, and T, and were part of the OpenTelemetry family. But they knew there was a big incident disguised as a wolf that was lurking around. And so they built some mechanism to defend against it. But of course, then came a day where the wolf came down in the village. So M was the first one on the escalation chain. So M was like, hey guys, I put in place metrics, the signals that trigger the alerts, and I can show nice trends on dashboards. I can help figure out what's wrong. But that definitely wasn't enough
to go against the wolf incident. Then L was called to jump on the bridge. L was saying like, hey guys, I'm pretty clever, so I'm leveraging logs. I've got all kind of details of all sorts, structure and structure. Surely we have the root cause somewhere in that, that old pile of data. So we'll go against the wolf, but unfortunately there was just not enough context to scare the wolf out. So wolf is still around, incident's still around, clock is ticking. So then only T was remaining, and T was strong because what he built requires significant instrumentation and significant efforts to implement and provided richer data. So T cell, well, I can tell where W comes from in that old forest of 50-something microservices dependencies. All right, wolf incident started to shudder a bit, but it just wasn't enough to find its weak point. So doom was looming upon our friends until Mother Hotel called the near cousin the mighty P. So mighty P came in and had a quick huddle with M, L, and T, and he said like, listen guys, I don't have the full picture, but I have some very specific details. I'm sure that together we can vanquish the wolf. So then P brought in profiles with code level visibility and flame graphed away the big back wolf. And developers travels from far away to see the wonders. So from now on, P was considered equals to his cousins and part of the family, and with the dev, DevOps, and SRE community, they all live together happily. So for now, for a little while, actually, profiling made its way to be considered as being the kind of an official fourth signal or fourth pillar of observability. And when you think about it, I think it only makes sense, right? The lack of code level visibility is the gap that it helps to fill. And that's a huge gap, like what that once filled is very, very helpful to find root cause. But you might say, hey, Steve, in your story, what's the thing about open telemetry, you know, the open telemetry family and the modern, you know, the village called CNCF and everything? I thought hotel is only about traces, logs, and metrics. Well, yeah, you're right. Well, until now, right? 2 years ago, in 2022 at Kubecon Europe in Valencia, there was a profiling SIG, so special interest group, that was created to work on the profiling data model. And this year at Kubecon Paris, OpenTelemetry announced the adoption of the profiling model in its specification. And the target is to have a stable implementation later during the year. There's a blog post about it, but that's of course, that's a significant announcement, significant change in OpenTelemetry. But let's take first a step back, right? First of all, what is profiling? So who here is using profiling like frequently? Okay, so a few, but it's not like everyone is doing it. So maybe, hopefully you'll learn something today. Well, profiling is a way to do deep dive, right? Deep dive code level analysis, and how your application are using resources such as, for example, CPU or memory. Profiling itself is not really a new thing. It's not a new concept. It's been around for a very long time, actually. So if you think of like profilers that are built-in developer tools like IDEs, or something like dtrace on Solaris. So Solaris, long time ago. So dtrace includes some profiling capabilities. Now for some languages, for example, Go, the Go language, the profilers are built in the runtime. If we think of conventional profiling technologies, one of the issue is really related to the profiling. Not the profiling, but the overhead on the profiling. So when you do on-demand profiling, it requires, it's a more kind of proactive approach, right? So you have to, with like the more conventional profiling technology, you have to go, you have to do an SSH on the machine, you have to start a profiler, And then you got to collect the profiles, and then you have to analyze those profiles. You cannot leave it always running because the overhead is too high. So that's the traditional profiling. And that's one of the caveats. So what's happening is that, if you have intermittent issue like related to performance or memory, if the issue happened yesterday, or if it happened just 20 minutes ago, you missed it. You need to go trigger the profiling when it happens. If you think about it, it's a bit like, taking a signal to your patio with your camera and hoping to be able to take a picture of a unicorn crossing your backyard, right? You just won't get it, right? So you always hope you'll be able to catch it on time, but you don't. Also, what's happening with modern, highly dynamic, ephemeral environments is that they always change. They're always fluctuating. They're very complex. So having to install profilers, having to retrieve profiles that manually just doesn't work. But profiling technology have evolved over time. What is done now is doing sampling on the call stacks, and that results into low overhead, an overhead that is low enough so that it is acceptable to be running in production. And what this allows is to be able to do continuous profiling, right? So you can, by doing continuous profiling, you add the dimension of time to your profiles, and that unlocks a number of powerful use cases. For example, once you have profiling always on, it becomes a tool that is more proactive than reactive, right? Because it's always measuring, and then you can trigger alerts based on those. You can compare resource usage over time, for example, over different releases, over like good versus bad situation, before and after an incident, things as such, because you're always collecting. I'm not here to sell you like the concept of continuous profiling, but there's definitely some also value that is more kind of at the business level. So, if you understand in depth exactly where the resources are being used, whether it is CPU or the resources are allocated when it's memory, you can use that information to optimize your workloads and to reduce the cost. So there's some cost-cutting benefits to use continuous profiling. There's also the matter of performance. For many businesses, high latency is shown to be associated to loss of revenue. You think of like e-commerce, low performance affect the conversion rate. Think of advertising. Think of also customer churn for things such as online gaming or media streaming. Or sometimes also reducing the latency can increase revenue. So if we think like HAFT, for example, high frequency trading, fintechs, rideshare. So just having better performance, it's not about losing revenue, it's about increasing the revenue. So there's definitely a revenue aspect associated to improving the performance, and continuous profiling can help on that. And of course, there's the most obvious benefits for people who are working in ops or SREs is the ability to get the information, the right level and the deep dive insights to be able to pinpoint to issue, CPU spikes, memory leaks, and be able to get all the details to resolve an incident. So how do you gather a profile? But when it comes to collecting the profiling data, there are two ways that you can collect the data. User space level. So if you work at user space level, you're going to have like popular profilers such as like, for example, pprof, or depending on language like RBSpy, PySpy, .NET Trace. So they operate at the user space level. You can also collect at the kernel level, so using eBPF profilers. So they're able to get the stack trace for the whole system from the kernel. Pyroscope is designed to be language agnostic and also supports ingesting profile either using one or the other approach or both approaches. So you can do with both, or you can select if you want to do if you want to use profilers or if you want to do use eBPF. There's I would say there's definitely some benefits, some drawbacks with some of the approach. For example, if you go with instrumentation using SDK, you're going to have more detailed runtime information. Especially crucial if you want to get memory management and garbage collected languages, you'll want to go with the SDKs. Also for languages that are interpreted, like for example, Ruby or Python, this is pretty much the only meaningful way to extract stack traces. You'll need to go with the instrumentation. You'll need to go with the SDKs. Some of the challenges of going with the SDKs, you need to be able, of course, to change the application code. So you need to have access to it because you need to do some instrumentation. Sometimes the instrumentation can be very light, but you still need to do something like include the library, something like that. Also, the profile most of the time will needs to be enriched with metadata information. For example, Kubernetes workloads, you want to be able to attach pod name, namespace, things like that. So you need to add some mechanism to be able to include that metadata information. For eBPF, well, it's good for compile or unsupported languages. Think of things such as Golang, Java, C++. So eBPF will do a pretty good job in those cases. The thing, though, like some of the drawbacks if you use eBPF is mostly focused currently on CPU profiling. But there's usually no memory or contention lock profiling that is available with eBPF. Also, if I get a little bit deeper into how it works, like symbolization is art with eBPF, right? So there's a lack of stack pointers. Require debug symbols. You'll require those symbols. You'll require to use a symbolizer to be able to get something meaningful from the eBPF instrumentation. And of course, when we talk about eBPF, there's kernel dependency. So you need to be running on specific Linux kernel version. Most of the time, like the recent ones will be all right, but sometimes there's something that you need to be aware of. If we take a quick example, a quick look at Go, okay, how it works. You're going to have a standard library that will include CPU, memory, Go routine, mutex, and block resources. So be able to do profiling for those things. And the profile will be provided using an HTTP interface. So you're going to have an HTTP interface that you're going to query and it will return the profiles. And the profiler is called pprof. The profiling information is returned in protobuf format. And then, you consume that using the pprof CLI. So you call pprof, then you've got your endpoint. Here, I want to have, like, for example, CPU profiles for the last 2 seconds. Here, I want to have heap dump. So I want to have heap memory allocation, and that's what's going to be returned. And then you use some tool to visualize the profiling data using a web interface. And there's multiple ways to visualize that. I'll touch a bit on that after that. So, of course, you can go to look at the Go documentation to get more details on pprof. But as I mentioned before, pprof is coming with the Go runtime, so it's not an additional thing that you need to install. For the other languages, that will be different. So, quick snippets, just import pprof. In my simple example here, I provide an endpoint, and then I've got things like 2 methods. One that is do a lot, the other one is do a little. So do a lot takes longer time to execute. Do a little takes, of course, shorter time. And my main is also spending three CPU cycles just to do that. So what is measured? So what is measured? Well, what I'm seeing here from that snippet, I've got my main that takes 3 CPU cycles. Then I've got my do a lot. Do a lot also have a prepare function. Prepare function takes 5 CPU cycles. Do a lot 20. Prepare 5 in do little because that's the same function. But do little just take 5 CPU cycles too. So that's one way to see the profiling data. That's what we call the table visualization. Pretty easy to understand here because pretty simple code. But in more complex code, table visualization is very difficult to extract the information that will tell you where the hotspot is. That's why people use flame graphs. So flame graph, if you're interested to know more about flame graph, because there's really tons and tons of information, I refer you to Brendan Craig website, brendancraig.com. I'll provide the link with the presentation after. Also on his GitHub repo, he's got a variety of tools that you can use to visualize flame graph. It's explaining the different types of flame graphs and everything. So he's pretty much considered the godfather of flame graphs. So great information. We also have from the Pyroscope team, flamegraph.com. So that's a way where that's a place where you can upload your profiling data, and then automatically it will be shown in flame graph formats. So that's a good way, kind of sandbox to visualize things. So how flame graphs are working. So the width represents the resource use, whether it is CPU or memory. In that case here, it's CPU time. And then you have the ability to spot Eiger usage in the nodes. And there's different colors, so it's color-coded based on the packages in the code. So which package in the code, if you change package, then the color will be different. It's typically how it works for any tools that are leveraging flame graphs. What I've been showing before is just profiling. It could be profiling on demand, right? Ad hoc profiling. Now, if we talk about continuous profiling, remember, we're adding the dimension of time. So what does it look like? Typically, most tools will provide this kind of things. Of course, you'll select a time slice, right? So you say, oh, I want to capture for the last hour or from this start time to end time. And then you have some kind of query language or some kind of ways to query what I want. So you're going to use things such as labels or tags to specify what kind of information you want. You'll be able to see the resource usage over time, and then you're going to have the information as in table format and in frame graph format. Tonight I'm focusing on Pyroscope. Pyroscope is an open source profiling solution, now part of Grafana. I'll touch a bit more on that, of course, later on. But I just wanted to quickly mention that there are other tools available in the continuous profiling space. Pixie, CNCF Sandbox project, so open source. That's one of those. So you see again here, interestingly, the flame graph is kind of inverted compared to what we've seen before. There's also Parka, another open source project. For which there is, because I'm going to talk about Grafana because I work for Grafana, but there is a data source plugin available in Grafana to visualize flame graphs from Parka, right? So Grafana is not just about using our own projects. We're open source, we're open standards, but we also have tons of plugins that can connect to external tools, and we have one for Parka. There are proprietary profilers, such as Elastics. So Elastic, a little bit counterintuitive because Elastic thinking, well, they used to be open source, but yeah, their profiler is proprietary. And of course, Datadog. Well, what Datadog doesn't have, right? So they have a profiler. And there are other players. Of course, there's like Splunk, Always On, their own profiler. And of course, the big three cloud providers also have their own profiling services. So there's a Cloud Profiler for GCP. There's a Azure Application Insights Profiler, and there's also AWS Code Guru Profiler. But let's talk about Grafana Pyroscope. Quick story. A year and a half ago at Grafana, we launched a project. Maybe some of you heard about it. It was called Flare. So at Grafana, it was our own open source continuous profiling project. The idea that we had at the time was to leverage the same kind of highly scalable, cost-efficient architecture that we have for our other telemetry stacks, such as, for example, Mimir, Loki, or Tempo, and apply this to profiling. So we started to work also on SDKs and profilers. But at the same time, we partner with Pyroscope. So Pyroscope was a kind of different company. And actually, we were even using Pyroscope internally to monitor our own things in terms of profiling because Flare was not ready. One of the things that Pyroscope had is that they were way more advanced than we were in capturing profiles into the support of frameworks and languages. So they had, I would say, like easily a couple of years of advance. But the Flare architecture was kind of more scalable. So we thought, what if we could combine them? And then we entered into discussion, and Pyroscope agreed to join Grafana Labs. And since then, we kind of sunset Flare, and now continuous profiling is Grafana Pyroscope. I'm just going to quickly quote Ryan Perry. He's one of the co-founder of Pyroscope on why they joined Grafana. So one of the power they've seen also of joining like the Grafana family is, both their open source and their commercial users, although they were using and they love using profiling data, they wanted to see the profiling data to be used and correlated with the other telemetry signals like metrics, logs, and traces. And a lot of those people were visualizing those things from Grafana. Grafana is, in terms of visualization and UI, is very pervasive. Like it's found, I'm still surprised, almost every company I'm talking to using Grafana somehow. So they thought, okay, that would be great if we could be part of that. So if we would be working with the company, the people on those projects, it would be much easier to be able to integrate in the power of profiling. It's powerful on its own, but it's way more powerful when you can correlate with traces, when you can correlate with logs or metrics. So how does it work? Well, first, you want to collect the profiling data, right? So that's on the left. Pyroscope will collect CPU and memory profiles from application that expose profiling endpoints. And there's different profiling endpoints depending on the language, right? It's very language specific. So there are typically two approaches. There's manual instrumentation, so the SDK instrumentation I've been talking about, or you can use the Grafana agent. Grafana agent is an open source agent that we have. Beats a scoop. It's going to soon be renamed. So we have a conference in a couple of weeks, Grafana Count, and we have an announcement. So the Grafana agent is going through major changes, but it can be used to do auto instrumentation for some languages like Java and Go, and also leveraging eBPF. So we will automatically do the instrumentation with eBPF. So once you have your application reporting profiling data, whether using the SDK or auto instrumentation, then you're sending that profiling data to the backend. And the backend can be Pyroscope open source. So you can get started with Pyroscope open source in minutes, right? You can spin up Pyroscope in a single process. So it's what we call the monolithic mode. And when you're ready to collect profiles from more application and you want something that is more scalable, then you can, and also have high availability and everything, what you can do is deploy Pyroscope in what we call microservice mode. So you're going to deploy it typically on a Kubernetes cluster. I'm going to talk a little bit more about that in on the next slide. What you can do also is you can use Grafana Cloud. Right? Grafana Cloud Profiles is the managed version of Pyroscope. So Grafana Cloud is a commercial offering, but there's also a free tier available. So it's one easy way to get started without having to deploy any kind of backend. And then you visualize the data using Grafana. Either if using Grafana open source, there's a Pyroscope plugin. If using Grafana Cloud, there's a Grafana Cloud profiling application. So what's the difference between plugin and apps? Plugins are just like something that you can use to build dashboards. An application has more workflows embedded and everything. That's something that's more specific to Grafana Cloud. So about the architecture. So Pyroscope, like I said, in microservice mode, it's been designed to be multi-tenant. And the architecture has been aligned roughly to correspond to what we have in terms of design with the other observability stacks like Mimir, Loki, and Tempo. So we have two different paths that are independently scalable, the read path or ingest path and the write path. So if you need more ingest capacity, you can independently scale those services, and you don't need to scale the right path. Or if you need more querying power, then you can independently scale the right path. The profiling data, the short-term profiling data is kept in memory in the ingester for performance. You can see the query can directly query the ingester. And periodically, the ingester will write to object storage. And for longer term query, it's going to query the object storage. The object storage is just a very cost-efficient way to store a large amount of profiling data, because what's happening with profiling is that it can collect a lot of data. So it requires a lot of storage volume, and object storage pretty cheap. There's another component that just deduplicates profiles in case there's duplications, called a compactor. So that's roughly the architecture. And for those of you who've been in the last time I spoke about the observability stacks from Grafana, I was talking a bit about the architecture of Mimir, Loki, Tempo, similar kind of architecture. So as I already mentioned, how you can use Pyroscope, there's the open source project, 10,000 GitHub store or whatever. There's also the commercial managed offering, Grafana Cloud. And Grafana Cloud also has a free tier. So you can sign up for Grafana Cloud. We're not asking you any credit card number or whatever. You have a 2 weeks full on trial, and then it stays free forever. There, of course, there's some limitation. You can get up to X amount of metrics, X amount of logs, X amount of traces, X amount of profiles, but it's good for playing around. It's good as sandbox. It's good for pet projects and things like that. If you don't want to have to stand any Kubernetes cluster to run your things or run things on your machine, you can just run it on the cloud. So quickly, I'll go through a quick demo just to give you an idea of what it looks like. The demo app is called Rideshare. So very simple. You pick up the type of ride that you want. The workloads are deployed in different regions, and each of them are reporting profiling data to Pyroscope server, and there's a load generator. All right, so we start with the Tag Explorer in Grafana, and then we just select our service. So here I have Rideshare implemented different languages. I'm going to pick up Go. It's going to refresh this. I can decide which type of profiles I want. So here I'm going to take CPU, but I could have like, you could use for like in-use object in memory, in-use space. But there's different type of profiling data that I can pick up. The data is tagged, so I'm going to say, well, I want to group by, I could group, for example, by vehicle. Here I'm going to group by region. So now I have a breakdown of the CPU utilization by my different regions. What is powerful with profiling is comparing, right? To be able to compare a region versus another, compare a release versus another, for example. So here, what I can see is that my EU North seems to be consuming a lot versus the other. So I want to be able to compare it. So I'm going to use it as a baseline, for example, US East, and then I'm going to compare it to EU North, say compare tag. And now I'm entering the compare view. And then I've got flame graphs for each of those. And what I can see here is like this find nearest vehicle taking 12.5 minutes. And here it's about 1.15 minutes. So it's a little bit more than 10 times of CPU consumption for this region, that is EU North versus this region. And then looking at the frame graph, you can see, okay, there's a mutex lock. I don't have the mutex lock on that side. And actually that's the biggest contributor, that's a contributor to that high CPU usage. And that's, of course, the problem pattern that's been injected for the demo purpose. But that's typically how you would do like you would just compare things, and then the tag here was region, but could be release, could be anything that is relevant to your application or business. What you can do also is that you can upload files. So let's say you're doing a manual, you trigger a manual profiling, and then it's going to create a pprof for a JSON file or a PB file. Then you can upload it, and then you can visualize it. You can visualize it in single view or corporation view. So you can also work not only with continuous profiling, but also with manual profiling, adapt profiling. One of the power, of course, is when you bring together multiple type of signals. For example, here I have Prometheus metrics above CPU utilization, but coming from a node exporter. I have logs that's being collected also, and I have profiles. And of course, I could have like also other type of data. But the thing is with Grafana is that you can bring all of those different signals together. And visually, when you're able to look at those, it's much quicker than having to go through different windows, different tabs, different computers, different subject matter experts to be able to collate all the data and figure out what's going on. One of the things that we're working on and we released maybe a month, 2 months ago is what we call span profiles. So if we do, here is doing distributed tracing. Right, so you know what a span is? Right, so span profiles is a way to attach profiling information to a span. So when you look, for example, at a trace, and I'm going to close this here. Oops, not this one. Hold on a second. I'll try to have one that is more interesting, if I can find one. I had one before, but I should have refreshed my screen. All right, hold on a second. All right, okay. It's not the best example, but you'll get the idea. So what I have here is I have the order vehicle span, and I have my span information. I could expand, get my span attributes, my resource attributes. Here I have the flame graph attached to that span. Because what is nice with distributed tracing when you get into complex environment, microservices environment and everything, well, there's a lot of dependencies, there's a lot of things going on. You try to find maybe a bottleneck. So the trace will tell you where the time is being spent, but it won't tell you where in the code unless you over instrument your tracing, and that you end up with other kind of issues. And that's where you complement with the profiling information. So I could say, well, show me the profiles for this span, or I got the flame graph available here, which is pretty powerful because it provides you the code level visibility for that specific span. And finally, one thing that we're currently working on, I wouldn't say it's GA, but we're adding, yeah. No, it's a sample because it's really associated to this span. So the way it works is that when you do like you do your instrumentation for tracing and everything, when the span, the profiling information has been collected, is going to be attached to a span. There's going to be a span ID that's going to be attached. Oh, like this? Yeah, this is aggregated. Yeah, this is aggregated over time, like, right? So I'm looking for, like, for example, maybe the last hour or something like that for this region, and for this region, this is all aggregated over time. Then I can slice and dice by tags to get more specific about what I want to see. Yeah, the last thing, like I said, like flame graph, powerful, but sometimes people say, well, it's difficult to figure out what's going on with this flame graph. So as with many other things currently in Grafana, we're providing the ability to generate explanation using LLM. So you can connect to OpenAI or other things. And then it's going to provide you an analysis of the flame graph. So it's going to explain you the flame graph in English. I'm saying it's still in work in progress because sometimes I've seen some errors, but it gives you some idea. It does a pretty good job. So we're adding those kind of capabilities in multiple places in the product, but profiling is one of those where I can say I've seen very impressive results. All right. So that's pretty much it. Like if you want to get more details, of course, we have the documentation. How, for example, to what we call like the client documentation is pretty much how to collect profiling data for the different languages or with eBPF, all available in our doc. And also more resources. Well, we have examples in GitHub on the Grafana Pyroscope repo. So example on how to instrument different languages, sample apps, things like that. We also have the Slack channel, the Pyroscope Slack channel on the Grafana community Slack. Of course, the official documentation. And ear-nose-play.grafana.org. It's a kind of sandbox for Grafana, like it's available for anyone. You can just go to that URL, and then you can play around in Grafana. Well, recently we added the Pyroscope app. So now you can look at profiling. What I've been showing, you can play around, you can click around. You can break, play, it doesn't matter because it's going to heal itself eventually. So everything should be all right. All right, so that's it for me. Thanks, everyone. Any question?
Thank you, Steve. Before I'm going to ask questions, Marat, you want to get set up? Because we have one more final talk. We have refreshments added. There's more soft drinks. There's beer if you want to grab. There's still a bit pizza left, but I'm very interested about profiling, but like how I can, talk to my manager so he actually says, yeah, like, you can invest 6 months of work to implement this. What we should tell to the CEO of the company why we should do profiling.
Well, like I said, it's a national kind of weapon in your arsenal when you're fighting for incidents. Yeah, it's definitely save costs because it saves on resource usage, right? CPU, memory. When you run things at the cloud, a lot of people forget that they're paying for those resources. So when you do changes to your code, sometimes you need to add some additional features, some additional functionality, but you increase the cost maybe by 15%. You don't even know about it, right? So that helps you to first identify that there's an increase in the cost, but also pinpoint where in the code so the developers can optimize their code, but they know exactly where. So it provides the insight, the valuable information on what they need to focus on. It's not, of course, I've been talking about SDK and instrumentation, but it's not that much of a heavy lifting. It's probably even easier than implementing distributed tracing. So I think it's definitely worth like to be used. Like I said, it's just the problem before was that continuous profiling was not really widely available. It was mostly manual profiling. Manual profiling is kind of a reactive approach. You're trying to launch something on a machine, the issue already happened, it won't reoccur again. You're trying to reproduce an issue in a test environment, in a pre-prod environment. Now with complex environments, cloud-native environments, no environments is the same, right? They're all different, and they're always changing. So with continuous profiling, you're always collecting. So you have the data, you can go back in time, and then you can do your analysis.
Awesome. We have more questions.
Thanks for the demo. It was very interesting. You said there was some overhead, but you didn't specify by how much.
The overhead will vary depending on the profiler you're using, but typically it's going to be, with continuous profiling, it's going to be around 1-2%. So what is deemed to be acceptable in production if you consider like the value that it provides. Of course, like people say, I want 0, but then, okay, no, you get nothing and no value. If you look at like some of the older, more traditional profilers, sometimes they could go as up as 10%. And definitely if you use profilers like integrated with IDE, it can be 50% overhead. It will just kill your app, right? You never run that in production.
What about the additional storage requirements? Because now we have metrics, logs, distributed traces, and if we add on top of that profiles, by how much it will increase the data requirements?
Okay, so yeah, so the questions about the storage requirements. Of course, it's more data, so it's more storage. But the way that Pyroscope, it's one of the things I didn't explain because I don't want to go for an hour, but there's one thing that Pyroscope did specifically versus the other profilers is that they've been very careful about how the data is being stored. So they found all kind of ways to make the data storage as efficient as possible. So for example, they use tree structure, so to not having to duplicate the information, to be able to be as efficient as possible and as compact as possible in terms of storing the data. And then using object storage also make it pretty cheap, right? Versus having to store on disk. If you deploy this thing on servers and then say, well, I need to store this on block storage, it's crazily expensive, but object storage is, I think it's pretty cheap. Well, I would say cheap, but let's say cost efficient, right? So yeah. Does that answer your question?
All right. Yeah, I think we're getting close to the time, but thanks a lot, Steve. And I hope, like, I had experience working with many companies that's using profiling, and usually those are like Spotify, Shopify of the world, like Facebook, like the cool companies. I think like would be great to see more like, you know, other like companies can benefit from the functionalities of profiling. And I think we're just like trying to like educate people how this can be helpful. We have slides going to be available in this link. The post-event survey, like we still have just want to make sure if you decided to leave earlier, but we have an announcement for the winner of the, what is it, iPad or AirPods? Okay. So yeah, Fahmi.
All right, thanks, Archie. Hello, everyone. I'm Fahmi. I'm with Achilles, and I just wanted to announce the winner of the AirPods. Unfortunately, marketing did not send it to me in time, so when I announce the name, I will have to get in touch with you, and then we'll ship it over to you. So I have a randomizer here. I'm just going to go through, click it a couple of times, and then I'll choose the number 1 on the list. So here we go. A few more times. I'm not looking. All right. Number 1 is Ahmed Khater. All right, congratulations.
Thank you. Thanks a lot. And we have supposed to have champagne, but we decided with cupcakes today for Falco graduation. I don't know if you attended our last meetup. We had like just like kind of introductory Falco, like how it do runtime protection. I think Marat wants to share some new things that came out from Falco World. Welcome, Marat.
Yeah, thanks, Archie. Hi, everyone. So yeah, my name is Marat Salahutinov, and I'm Senior Customer Solutions Engineer at SysDic. And today I will be talking about remediation of Kubernetes security threats in real time with Falco Talon, which is additional tool that comes out soon. It's not fully released yet. It is in beta version, but I will showcase how it can help us to auto-remediate any security threats in your environment. Okay, this is me. If you want to connect, just scan that barcode and we can connect in LinkedIn and you can reach me out. And if you have questions, we have some nice Falco labs at SysDic because we are one of main contributors to the project, right? And yeah, I will love to answer to your questions. And about myself, I'm Marat, obviously, and I have been doing IT more than 15 years. Started with all the simple things, system storage administration, I don't know, racking, cabling stuff, and slowly and thoroughly moved to cloud and Kubernetes, basically. And now I am doing security in cloud and Kubernetes, basically. And I love Kubernetes, and here is the proof. I got these custom plates in Quebec, and I wasn't sure if I would show this once more because I shown this last time already, but I decided to show it once more, and I will not show this anymore. So anyways, let's move on to the agenda. So we did introductions. We will go over some topics, runtime security, why, what is Falco, how it started, just to go through the whole journey before it graduated, basically, from CNCF incubating status. And I will walk through Falco Talon. And then I will do a demo like I did previous time, the same scenario, but what if we would have a Falco Talon and nothing would happen, basically. So yeah, let's move on. Runtime security, why? So here I have two slides, basically. One is our SysDig's global cloud threat report. You can scan the barcode and basically get the full report, but there are five main outcomes from that, right? Cloud automation weaponized, basically a lot of like threats and attacks are fully automated. Basically some groups like try to detect certain vulnerabilities, attacked, and basically inject their code, start mining some cryptocurrency, and all these simple things, basically. Then 10 minutes to pain. It takes only 10 minutes to break into the system. And finally, that third point, which I want to highlight, is 90% safe supply chain isn't safe enough. So it means even if you try to avoid all the vulnerabilities in your images, in your software, in your, I don't know, hosts, it's not enough. There is still a chance that you will get some zero-day vulnerability or some other issues. So, coming from that, SysDig just introduced the 555 benchmark just to be able to stay against security threats in the modern cloud environments. It is 5 seconds to detect the threat, 5 minutes to correlate and triage, and 5 minutes to initiate a response. So basically, that's why runtime security is really important. And Falco and Falco Talon as a response engine can help us to achieve this benchmark and be within this benchmark. Any questions so far? Yes.
Does Falco Talon and Falco qualify as antivirus solutions? I know they don't, but that's one of the big questions I always get from clients, technically.
That's very good questions. It is not. But talking about that, you know that Falco came out from SysDig, right? And within SysDig, we already introduced this kind of module that is doing malware detection by the signatures of the binaries. So technically, there might be something coming for Falco too, but I don't have that information. But well, it is not.
It's obviously a solution for containers, and it's different. But because governments are very annoying, they always request to have antivirus solutions. And for example, we have Falco, and we're thinking about Talon, but it doesn't qualify because of a stupid nomenclature. It's not an antivirus.
Well, I mean, by the definition, it doesn't qualify, but some of the customers are using it, right, in similar ways. But definitely, it doesn't qualify. Yeah. Anyways, you mentioned that it is for container and Kubernetes, but in fact, Falco can be run on the host also, and can do the same detections on the Linux host as well. Anyways, let's move on to the next slides. So what is Falco? Falco is an open source runtime security solution for threat detection across Kubernetes, containers, host, and the cloud. So this is the more or less official definition. It's cloud native and basically more than 60 million pulls from the Docker repository registry, right? And it's about 100 millions altogether with other sources. And finally, it is a CNCF graduated project. It is graduated in February 2024, and there was a lot of interesting talks about this during Kubecon in Paris, basically. So yeah, let's move on. So we call it security camera for modern apps. It can look into applications, how it works, basically. In the runtime, when we are talking about instrumentation of Linux host or Kubernetes, we hook up to the kernel. Either it's kernel model or eBPF over eBPF, right? And then we look through the syscalls, and based on that syscalls, we build our Falco rules and go through that syscalls, detect certain activity by using those Falco rules and generate security events, basically. So what is Falco? It's a runtime security engine, right? Observability for endpoints and cloud infrastructure. And when we are talking about cloud infrastructure, we are talking about the plugins. So in 2021, 2022, we introduced these plugins. Logic, basically, you can develop your plugin, hook it up with our Falco API, right? And then basically forward any kind of events, logs, or whatever you want, basically, that is parsable and repeatable, kind of, and parse that through and basically generate security events. And I will talk about that a bit later. Built in on eBPF, initially it was kernel model. There was ptrace option also. Now it's we introduced recently eBPF core. Compile once, execute everywhere, right? Universal driver, we call it. And with that solution, all the new kernels are supporting it, and it's making our life much easier. We don't need to compile different drivers for different kernels. And integrated with Kubernetes, it can get all the metadata and connect it to the security event, and you can basically look through that and correlate everything and figure out actually where it was happening. So yes, Falco rule, this is how Falco rules look like. Basically, it's a YAML definition, right? We have rule name, description, condition that would consist from some macros lists or some fields that you have. There is tons of different fields you can use related to syscalls, related to Kubernetes audit logs, and some other stuff. Then we have this output section where we would generate the body of security event, basically. Then we do priority. It's just notice in here. It might be critical, warning, or something else. And we just specify tags if we want to group the rules. Then alert would look like this, basically. This first one, terminal shell in container. Another one is netcat within the container. So, and I will be showing those type of events today as well. So beyond system calls and containers, as I was mentioning about plugins, so here is just small fraction of the plugins. GitHub, Docker, Kubernetes, cloud logging, Azure Log Analytics, AWS CloudTrail. Now new plugins are Okta plugin. We have anomaly detection plugin. We have another one coming, HashiCorp Vault plugin. So you can basically develop different plugins and use them with Falco. And another core components is Falco Sidekick. So basically, it is a component that you can deploy in your infrastructure. How it is useful, you can collect all the events and basically forward them to different receivers like Slack channels, I don't know, Opsgenie, or some other tools, like a lot of tools, different tools, and basically streamline the whole infrastructure, like security, to some specific places. And finally, a lot of people tell that it is open source, it is probably complicated and you wouldn't have support. But here is the some of the companies that are using Falco in production. And you can see it is a pretty big list. And you can find the whole list on the GitHub repository. And some of these companies are big contributors as well. For instance, on Kubecon, Apple and which one? I don't remember which one was presenting on the main event related to Falco graduation. So basically how it started, because today we were celebrating graduation, right? So first commit has been done in 2016. Then a new eBPF driver was introduced in 2018, and the same time it was accepted to the CNCF sandbox, right? And then Falco Sidekick was introduced in 2019. In 2020, it moved to incubation state in CNCF. Then in 2021, plugins were introduced, and I learned about Falco during my CKS preparation here the same year. Then in 2022, Falco CTL was introduced. This is an additional tool to pull different plugins and different rules from the repositories. And some enhanced governance. eBPF core was introduced in 2023. And finally, in 2024, we basically have this graduation. That's it. And what's new in Falco? So this is some list of new features just recently introduced. I was talking through some detection improvements, rule language improvements. We introduced override option, testing and stability improvements, some better coverage, new kernel and Linux distribution, performance improvements, rules maturity framework. We have different stages of the rules. Plugins, I was mentioning different plugins, and a new Kubernetes cluster metadata plugin that collects even more metadata now than it was before. Improvements in plugin API. There are SDKs now, C++, Go SDK, and another one is coming, Rust SDK. So anyone can basically develop their own plugins, right? Falco Sidekick has more outputs now. Dynatrace output, Sumo Logic, QuickWheat, and some other outputs were introduced just recently. Falco CTL now used not only for pulling plugins and rules, but also drivers. So it's a single tool now to do all the maintenance around Falco, right? And finally, we have now play.falco.org website where we can basically play with different rules. That's it. And this are some new features that are coming. So you can see adoption, deprecation policies, standardizing, streamlining, configuration, like all the different nice things, getting more distribution options also. And in addition to that, we have some future directions, Falco in third-party distributions. So we want to do officially offer it in different cloud marketplaces, include to the Linux distributions, and do some even more integration. And I was talking about anomaly detection and SDK for us, so those are coming soon too. And finally, these are resources that you can use for this. And I think I will be sharing slides with Archie, and you will be able to look through all those links. And what about Falco Talon? So, excuse me. So Falco Talon is basically a response engine. Falco is really good for detection stuff, right? You can detect different activity in your Linux host, in your containers, in your cloud environment, but you need to respond to those, and in some times you need to respond really fast, and Falco Talon basically helps us with this, and it is automatically respond to the different threads based on different rules that you defined. Very similar to Falco, but slightly different. I will showcase, show through how it looks like. So this is architecture. I just copied this from the GitHub. Simple view, basically, either you can connect it directly to Falco or from Falco to Falco Sidekick and from Falco Sidekick to Falco Talon. So in Kubernetes world, we do this installation all with Helm, and it is pretty straightforward, and I can showcase it a bit later, but in terms of rules, we talk about events, right? This is Falco security events that generated by some security problem in your environment, right? The rule where we define action, actionnaire, and notifier. So action is a set of actionnaires that would do something based on that event, right? And notifier is just to send that notification that something has been done to some different outputs. It can be syslog, it can be Kubernetes events, or some other output options. So this is how the rule looks like. So we defined action, terminate pod, and we added actionnaire Kubernetes terminate, right? And we do some parameters there. And then when we define the rule, we match rules here. We match rules terminal shell in container or netcat remote code execution in container. And output fields, we want to make sure that we don't check these specific namespaces. And action, we basically define that action that should be taken is terminate pod action. So this one, actionnaires, basically, we have this bunch of Kubernetes related ones. And we have also network policy related for Calico. So basically, based on the event, you can create different network policies for your Kubernetes namespace, right? And then AWS Lambda function if you want to do some action in Kubernetes, in the cloud environment. So notifiers, Kubernetes events, Slack, Loki, Elasticsearch, SMTP, Webhook, and some more are coming also. And installation, again, currently Helm chart is in this Git repository. As soon as it will be released, it will be with other Falco Helm charts, right? And to configure Falco Sidekick, you just need to specify a webhook address. When you deploy it in the same namespace, basically it's Falco Talon service that listens on this specific port. And resources, so those are resources. You probably can make a photo if you want to try it. So first one is the repository where it is developed. Second one is documentation. This YouTube link actually is really good. It's from CNCF live event where Nigel Douglas, the guy from CISDIC, who is one of the contributors to Falco, he is talking about the Falco Talon and basically describing how it works and in details explaining all these different actionnaires and other parts of the whole solution. And finally, this is his repository. And over there, you can see different testing options that you can try in your environment. So now it's demo time. Hopefully everything will work. So demo environment details. So from last time, if you remember, we had Kubernetes cluster running on the EC2 node with some vulnerable Kubernetes cluster on the EC2 node with vulnerable Spring Boot application, right? With Spring for Shell vulnerability. Then we have Falco as a daemon set on Kubernetes cluster, Falco Sidekick, Falco Talon, Falco Sidekick UI, Falco Cloud Trail plugin, and Falco AWS Cloud Trail Terraform model. So those are deployed components. And attacker host is host where we have some rootkit and other tools installed basically to escalate different privileges and to do some lateral movement. But for today, I will not do any lateral movement. I will just show the initial step, and I will showcase if we would have basically Falco Talon that nothing will happen further. So yeah, and talking about attack in this lab, we had this Scarlet Eel attack that was discovered by CISDIC again. So initially it was started from exploiting vulnerable application in Kubernetes cluster. Then they could access to some metadata server data and credentials stored there. We know that if it is IMDS version 1, then you can easily get credentials from there. And if you overuse and have excessive credentials in there, you can do some additional stuff in the cloud and do some lateral movement. So all this, the whole attack description, but we will be actually just doing the first part and we'll be stopping that first part. So now it's demo. And here you can see on the right side is Falco Sidekick UI with all the events coming from Falco basically. On the left side, we have attacker machine and we have AWS CLI also. So to start this exploit, I will just copy command from here. So we have this exploit available, right? So we just run it. And if it gives this kind of nice output with Chinese characters, right? Then we know that it is exploited in this particular case because this exploit is coming from our Chinese friends in the GitHub, basically. So that's it. Now we can run some remote commands on this system. So we can do some of this. For instance, we run here uname-a. We figure out that it is Linux box. Then we did here who am I, and we realized we are root. We are super happy, and we try to do some nasty things here, right? So what we are trying to do, we want to download Netcat and execute it towards our listening server. So we just run this code here. And we just received connection, so we can run some commands in here. And you can see on the right side, actually, right away, right below the root where we were downloading here. You probably don't see it. Let me try to make it bigger. So you can see on the right side here, right below the root, where we were downloading actually Netcat to the system. And then we actually executed Netcat to connect to our listening server. And we can see that events in here. So here we, on the left side, we can run some commands. Hopefully, yeah. We run this one. We can see that we have certain files here. We can try to do some other stuff. Here is our processes, right? Our application, our Netcat server, not server, sorry, client, and some other processes running there. So now basically we could do whatever we want. We would get that credentials. We would go and move laterally. But for this lab, we will not do that. So what if we would have Falco Talon in there? So to showcase that part, let's cancel this one. I have access to the host where I have all these Kubernetes pods running, right? And if we check here all the workloads in our Falco namespace, we see that Falco Talon is running, but I didn't enable initially that rule that would terminate our pod. So to enable it, I will just edit this config map. And basically here you can see two rules are commented out. So I will just remove those comments, right? And I will save this. So I save this, and to apply those rules, I will just restart it, the Falco Talon workload, just to make it faster, right? So kubectl, delete pod, dash namespace Falco, and we do Falco Talon. Yeah, we deleted this, and it has restarted. Let's see if we have the command to do logs. No, not in this view, but I think I have it in this right side view. So 1 second. Anyways, we can showcase that later. That on this side, let's do kubectl logs. And I will show the Falco Talon pod logs here so that we can see everything that is happening. So now we go back to attacker window, right? And we want to do the same attack, but with Falco Talon enabled. So basically we go back to this view, we go back to our instructions. We know that it is exploited already. We just want to re-download the netcat and then start it again. So we run this. And let's see what happens. Nothing is happening. And we know why nothing is happening. Basically, what happened here, our Falco Talon detected this event, and it is just terminated that pod. And if you check in this section, it will see that launch ingress remote file copy and terminate pod action on that specific rule where we start netcat. That's pretty much it. Basically, with this simple solution, you would be able to remediate some of the security events. The challenge probably is to identify which one you want to do auto remediation, with, right? And the ones like related to netcat execution probably the right ones, right? So you just need to play with it and figure out which is really important for your environment. But overall, that's it from my demo. And if I will switch to my slides, you can try it yourself. I created invite to the same lab, basically, where you have this Falco related lab and also very similar lab related to SysDic. So you can play with both and compare them and have fun. Thanks a lot, everyone. And if anyone has questions, over there. Yes.
Okay, thank you for your presentation. Just for a confirmation, as I understood, Falco is a cybersecurity tool which is reactive. It means it finds container threats and it fixes them, but it's not proactive. It cannot prevent those threats before entering to containers. Is reactive, not proactive.
Yes,
the cybersecurity tool.
Because it should be happening, and then you react to that event. But it might be like really milliseconds, your reaction.
When you have a thread in the container and after you start, you find it and you fix it. You cannot prevent entering the thread.
No. Falco cannot prevent in advance, but
reactive.
Yeah, absolutely. Interesting part actually within SysDic, we have additional components. We have drift detection and malware detection that is using FA Notify API that is used by antiviruses basically, and that one is preventing execution actually. But definitely in Falco we don't have that functionality here. Other questions? Here I think. Okay.
I want some clarity regarding the integration with the endpoint managers. I want to see whether I understood correctly that you have a, how do you say, an immediate integration with Dynatrace. Can you explain that? Can you add some color to how that integration is facilitated, what the modalities and what sort of inadvertent how do you say, incompatibilities are there, right? And what are the integrations with other endpoint managers? Are they as simple or is there a little bit more complexity?
Well, so question was how integration with Dynatrace works. The answer is I don't know because that one wasn't released yet, but I can check. If you send me some notification in LinkedIn, I can check and get back to you with that. For other integrations, it is pretty straightforward. I think all of them or most of them are supported by the Helm chart, and integration is a matter of like adding that specific values in the Helm chart and deploying that configuration with Falco Sidekick.
Thank you.
Okay, thanks. Other questions?
Thank you. I'm just wondering or curious about the difference between other CSPM tools, something like Prisma Cloud or Wiz. So I'd like to know the pros and cons of Falco, please, if you know.
Yeah, Falco is a runtime security tool, right? And Prisma Cloud and Wiz, they have runtime components, security components, and basically, I think Falco honestly would be the best in the field compared to them because that was how like container security was started pretty much. The very good part of Falco, it is very flexible, right? You have so many different options to create different rules. And basically, compared to other products, it is kind of black box. You don't know how they detect, and you don't have much options to fine-tune those detections. So that would be it. But compared to the full tools, Falco definitely doesn't do CSPM, it doesn't do compliance, it doesn't do vulnerability management. It purely does runtime security.
Oh, okay. Yeah, because I use both tools, but both are, there are so many that you don't know, like much black boxes, right?
Yeah, exactly. And you should try Sysdig. Sysdig is comparable to Prisma Cloud and to Wiz. That's pretty much like the similar level tool.
Yeah, it's more like the Falco is more like focused as a like CNCF project in Kubernetes runtime security, where what you're comparing is to the product, right? So it's kind of unfair comparison. But if you're just comparing into Kubernetes runtime specifically, I think Falco is like right now is considered to be the most popular and most like
we call it de facto standard in the container security.
But that doesn't mean like it covers all the aspect and spectrum. Right? It's like the project is focused on specific area, whereas like you comparing to the like products, security products that covers many different use cases. I had a question like if I think the problem like for me if like I would had a company myself like it's kind of hard to scale people knowledge to build all of these rules and like it's kind of you still need to like learn specific Falco domain language, like it takes time and then training. Do you guys planning to have something like LLM, something that simplify like you can say like I want to create like rule for this, like and it's going to be easier for people because like it's like there's so many different tools and there's so many languages like how I can like train my security team to know all of this Falco rules across company. Maybe you have like one or two smart guys in a team, but like they're gonna leave and then like the whole team is like gonna scramble like how I'm gonna build this and maintain.
I don't know. I mean, if you use LLM, it should be trained on something. But if you don't have something to train on, and then it's probably hard. If you would train it on Sysdig internal Falco rules, then it probably would be doing a really good job because we have much more rules. And honestly, we have a lot of them coming in and available in Falco rules itself. But we have Sysdig blocks where we keep introducing all these different rules. Which are added by default to Sysdig, but we are still sharing it with community and basically maybe training it on those rules with Falco rules can help stuff, but with that stuff, but
it's just it's hard to scale the knowledge, right? Like
from my knowledge, I don't actually know if there is some work happening, but I can definitely double check and get back to everyone because I heard in Kubecon it was super hot topic to use all the different AI.
I mean, it's same for Grafana. Like, would like to have like ask LLM to build my PromQL, query for this dashboard. Like, it will simplify work because like the DevOps team and SRE teams, they can figure out a lot of those things. But let's say developers that want to build, let's say, a dashboard, they don't know PromQL. So it's just like maybe this is a future state. Maybe in 5 years we just can ask the prompt and it's gonna like spit us up everything that we want.
What we can tell here, definitely, you can buy SysDic, and there is a huge threat research team behind it that is developing all these Falco rules, and basically you can benefit from those. For instance, that SSHD vulnerability that was introduced last Friday, everyone worked whole weekend because of that. Sorry about that. But our threat research team introduced that specific rule right away, and you could just have it and detect if this would be basically used this exploit and vulnerability.
Any more questions? Yeah. I know you're gonna have some.
As you were talking about LLMs, I thought of like a simple validator of the different rules. Like when you were structuring your different rules in Falco, is there a tool? Like I remember it's Cilium. When you want to do network policies, they have like a really good GUI where you can play with it and understand. Because I was having a lot of problem when I was preparing for my security, Kubernetes security. So you write a rule and you don't understand if it works or not. So is there a validator? Something?
Well, this is very good question. I know that internally in SysDic we had validator, but I'm not sure if we have it available open source. But I think Falco itself has some options there to validate those rules and to make sure those are having proper syntax. I think that one would be useful in this particular case. Yeah, absolutely. But I'm pretty sure Falco has that option that you feed the rules files basically, and it makes sure that they are with proper syntax. Another question?
For when you use Falco with the eBPF extension, but you have multiple projects or clusters in like a cloud provider, one of the challenging aspects is aggregating then everything in this singular pane for analysis. Because you can have like Falco and Falco Talon in each cluster, but you want to have everything pulled back at the main operation level. Is there any way to get to like Argo events or PubSub? Because right now it's like tightly bound the two solutions together. But is there any intent to have like a way to integrate it with Argo workflow, Argo events, or Google PubSub, or AWS equivalents or Azure equivalents?
But it is possible with Falco Sidekick. So basically, you would forward all the events to Falco Sidekick, and from there you can have all the different integrations, even Argo workflows possible.
It's a hub and spoke architecture, so there's no networking between all the projects.
Yeah, that's a very good question. I can check with the developers basically directly and see if that's on the roadmap. So basically you are saying integrate it directly with Falco and forward everything from there to somewhere.
Yeah. So I'm running kind of Falco and Falco, and I want to have Falco Talon in each sub project, but I want to have a control plane where it's forwarding everything, but there's no direct network connection. It has to be through Google PubSub or for like a Stack logging provider.
Yeah, that's a very good question. I think syslog and standard output and something else was there, but I don't remember precisely. So I will check with developers and see if there are some plans for that. Thank you. And just connect with me on LinkedIn and remind me the questions.
All right, we have actually not much left time. I apologize. We always want to have more time for discussions. Please stick around. I want to say thank you to Murat. If you have a minute, just like very easy survey helps us to get better for the next time. We are looking for speakers for next event in May in OVH Cloud. So come talk to me or Alex or anybody from our team. I'm happy to help you maybe to do your first talk. So we're really hoping to engage community. We'll have some speakers coming from Toronto, but like we really want to have local speakers and we want to help you to make this first step on the stage and then, you know, hopefully help in your career as well. But you're also going to help the community to learn something from your personal experience. So with that, I want to say thank you. Not saying goodbye. Like if you can stick around.
Yeah, thanks everyone.
I think there's something left, but not as much, I think. But we're still here to chat if you want to have any questions or discuss something.